I can think of at least 5 reasons to avoid imperative code. The first is inconsistent state. Imperative code is usually found in event handlers like this, or callback functions, but callback functions and event handlers are kind of the same thing. So, why do these result in inconsistent state? Well, this has to be close to the event source, but the event source is not close to the state it's trying to change. And so what you end up having is a bunch of statements in your code that affect state in other places. They control and change state from out of context. And then you have a bunch of mixed concerns here. Okay. So you have to work on this in isolation from other code that's controlling the same state. What is flag? Why are we switching it? We don't know because we only see that this line of code is here among all these other concerns, and we don't know why this is happening or what else causes this thing to happen. We have to go to the store and click on Find All References on this method, and then look across the entire app and see what's changing that state. And that out of context logic has consequences because while you may see that one of these state changes is happening when you're creating a new event, you may not notice that the other state change also has to happen. And so there's like an implicit dependency between these states because one of them has to happen after the other, but it's not apparent just by looking at each line of code in isolation. You like ideally you'd have the logic and the control logic together, and you'd be able to see what this is affected by all in one place. So when you create a new event, all you know is you need to update the first state, but by default, that's going to create inconsistent or stale state. So every new event you create is going to, by default, be buggy. You have to remember the downstream states that you have to imperatively update in order to avoid inconsistent state. I saw this in an app I just converted from imperative to reactive code, where the search term was not being used to trigger the search results. And so if you found another way to set the search term, the results would not update on their own. And so you would end up with stale or inconsistent state on the page. But with reactive code, it's impossible to go wrong because state change, the second state change, the downstream state change, is inherently dependent on the first state change. It is basically impossible for this to be incorrect if you update state change 1. So no matter how complex you get, no matter how many event sources are changing the top level state, this bottom level state will always be reactive. It'll always be consistent because it is tied to it. The dependency is explicit. It directly references it, and it always reacts. The second issue is state elevation. That is when you have to elevate state in order to make it able to be changed by multiple features. So if you have some state that's only being used by one feature, in an imperative app, you might have to make it accessible to other features because those features may have event handlers that want to change that state. So an example of this is that same event handler we were looking at earlier. This actually is only used in one feature, it turns out, this flag here. But it's being referenced in 3 features. The one feature that's using it and 2 other features that kind of should have nothing to do with it, but they do have to change it because it changes at the same time as this other stuff. So in order to accommodate this has to be put into a global store where it gets, it's on the same level as a ton of other things in the app, which reduces separation of concerns, and it's like combined with a bunch of other state. And I mean, it doesn't have to be this way, but the point is, it's up there in a globally accessible level in the app. And the first issue with this is it decouples that state from the lifecycle of the component. And so if you navigate away from that feature, it's not going to automatically be cleaned up if you're using observables to manage your state, which is a good idea. Or even if it's local state in the component or a service that's only being used in the component. Actually, if it's in the service, I think it probably stays the same because services live forever in Angular pretty much. So unless you provide it directly in the component. In that case, then yes, that's a benefit you would have, is it would be cleaned up when the feature is navigated, when you navigate away from the feature. So that's one benefit, is it matches the lifecycle of the component. So when you navigate back to it as well, it can trigger a fetch again. And so you can use that lifecycle of the component to manage state, whereas if it's in the global store, you have to manually control it. And I believe that's what's happening here. Actually, not with the flag. Here, this is actually search results. They called it delete movies, but it's delete search result movies. This actually doesn't need to happen because after I refactored it, this would happen naturally because when you navigate away from the search results page, it would, or if you type in a new search, it would just react to the URL correctly. So that was working fine. Because in Angular, the search parameter it was in the URL, it's an observable, and so it's able to react to that. So yes, being able to put state where it's used or co-locate it as much as possible makes it as convenient as possible to manage it at the same time, or have it consistent with the component. But the other issue is just a complexity issue, where if you have something in the store, anything can be changing it. And so how do you know what, you have to click on find all references in order to know what's being changed. Whereas if it's in a component, you don't even have to think about that. You just know what it's going to be because everything can be in one place. Or, in a service that's used dedicated to that component. Either way. This is what it looks like when it's reactive. The event has to be referenced by the state in the other feature, but the event is a very, very simple thing. The state itself will have the update logic and all the imports, all the dependencies it has in order to define that logic and the state itself. Whereas the event source can literally just be, it could be a string depending on what reactive system you're using, like an action type in Redux or something, or a simple action class. But with RxJS, it's just going to be a subject, and that's much simpler. And this is closely related to the third issue, which is larger bundle sizes. Because when you have an event handler, just look at this event handler. It has to import all the code for these features into this main feature. So if you're on the home page and you have a callback function like this, you're going to be importing all these state changes, all these state change functions, and it's all going to be in one bundle. And so it's going to be difficult to code split without doing a weird kind of artificial code separation. Whereas if everything is self-contained and reactive, it splits along much more natural boundaries. So that's what this looks like. This is what that looks like. With reactive code, your feature one, it's very simple. It's just got these events that these can even be in a separate bundle if you want, but these are from the first feature, and your second bundle only has to import these events, and then it can, Webpack or whatever you're using can figure out that it's only using these events. And so I drew this wrong. It's probably 3 bundles is what this would be. But anyway, all that update logic and state logic is going to be able to be self-contained inside that one feature. And the fourth reason to avoid imperative code is because of unnecessary complexity. So just like we have to have an arrow for every single update that happens and every new event source that needs to update the downstream state in an imperative pattern, each of those arrows actually adds complexity to the overall application state logic. But actually, there might be a way to simplify this. What if we create a function that updates state change 1 and takes care of the downstream state change 2 as part of it? That would tie the state change 2 update to the state change 1 update. And so every new event you have that causes state change 1 wouldn't have to add an extra arrow and all that duplicate code and all that extra complexity to update state change 2. It would just call, the complexity would scale the same way as I had the reactive diagram showing. That would be really nice. So let's see if we can maybe pursue this and make imperative code not super complex. So I actually made an app to experiment with this pattern and see how far I could push imperative code to make it maintainable in the same way that reactive code is maintainable. Maybe there's like an imperative version where we don't have to have inconsistent state and all these other issues I'm talking about. At least let's try to make the imperative code simpler so that we can get rid of that fourth problem with imperative code. That's really the goal I'm pursuing, actually. So in this app, I have a car model that is being selected, and that's where the first state change can happen. And there are multiple ways of causing a state change. So basically, you can select the car or you can reset it. But then you have 4 pieces of derived state. So yeah, all these things, I've defined this one function so that every new event can just call this function and then it handles these internally on its own. So I thought maybe this is a good approach. But we've got this update logic for electric range, and I know one of the benefits of reactive code is the ability to co-locate the state logic with the state it's changing. So what if is there anything that would prevent us from being able to define a function next to this state and then just call that function from here so that we can have this logic all in one place and it's still imperative, it's still calling it from here, and then we could also have co-location of state and state change logic. So that's what I did here. Now this top level state change function is not actually changing states, it's calling functions that are in charge of changing the downstream states. So these derived states here, where the state is located is next to the function that will change it. So this is nice co-location, and all the top level function has to do is call this function. But before there were 4 pieces of state it had to control. Now there's only 3. And the reason for that is because this last one, it defines itself, but also can take care of the state that's derived from it. So before there were 3 immediate derived states, and then an extra derived state that was derived from one of those other derived states. So that's what's here. This function right here is only in charge of controlling its own state, but then it has to call this other function to update the state that's derived from it. So this is actually pretty awesome. This could scale basically indefinitely, and it's still just completely imperative. And yeah, so yeah, this is pretty cool, I think. It's definitely better than what was before with this co-location of logic. But something kind of still feels off about it because we've got this car change, or this change car model function that's controlling the car model state, which is great. But it's directly referencing its own derived state. And down here, this state is referencing the state from above. And so this is sort of like a natural dependency here. It's derived state, so it's literally defined as coming from this state, and yet this state from above is directly pointing to the state change functions from below. But what if we wanted to move this to a separate file, or we wanted to distance it somehow, or decouple it, or do code splitting somehow? This right here has to still directly reference things below it, but I can think of a simple change that would actually make it so that this could be agnostic about its own derived states, and yet we'd have a similar mechanism to what we have here. And that is this, defining an array that can hold update functions. And so it doesn't need to know about them specifically. It can just assume that there are some derived states that have themselves pushed their own update functions to this, and now it can loop through them and update them. So this is better than this, because here we had co-location of state and state change logic, but we still had kind of a circular dependency between state and its derived state. With here, it can be agnostic about its derived state, and its derived state can completely control itself, and so it's automatically going to update just like it was before, except all this top level function has to do is every time it gets a new car model passed into it, it just updates its own derived states. So with that, we have basically invented observables. So here's a comparison. Well, here's what it looks like with observables, and then I'll open a comparison. I had to zoom out a bit, but it doesn't matter. The code is structured the same as with ArcsJS as it was with what we eventually came up with. So yeah, each piece of state is in control of itself, and this this map operator from ArcsJS, it's basically that update function that we were doing before. It's even better because now this update logic with our own mechanism, the initial state was treated as its own special like circumstance, its own special concern, and the update logic was duplicated. Basically, it's the same code but duplicated. Over here, initial state with ArcsJS, it's kept as kind of the same concern as every other update. It's just an initial update, and so the initial value will be processed the same way any other subsequent value is. So going from our implementation from on the left to the implementation on the right with ArcsJS improved the code quality. And do you see anything that we did along the way that didn't improve the code quality? From the original update function to better co-location with state change logic and the state it was accessing or controlling. And then from here to getting rid of that weird like circular dependency all the way until ArcsJS. Every single step of the way improved the quality of the code. This means that everything you can possibly do to improve imperative code makes it more reactive. So the only way to get good imperative code is to have less of it, basically. And everything we did along the way can be basically summarized with this rule of reactivity. Everything that can be downstream should be downstream, or everything that can be reactive should be reactive. There's another way of saying that. And it's the same goal that we followed through that 4-step process, and it happens to be the best way to get minimal and simple state management. So downstreaming state improves code quality at every single stage. So whatever your code is at, whatever stage it's at, the answer is make it more reactive to improve the code quality. And as a final benefit of this, I mean, every step of the way simplified it and organized things in a more logical manner. But as an extra benefit, once your code is all located together, all the code that's next to each other is relevant to whatever's next to it. That gives you opportunities to see things that are redundant or see things that can be coordinated better because the same concern is located in the same place. And so you're not going to duplicate concerns when you have mixed concerns or like you would with mixed concerns. So when it's all centralized, everything related to switching this flag is all together. You'll see, wait a sec, this is reacting to that, and it's also reacting to that, but those do the same thing, so it's always going to be this. So basically, you're going to see that every time it's changed, you might see another thing change, and you'll realize, oh, this actually has a reactive relationship. And so you'll simplify things so that you only need to make a single change with all your events, and then everything can be downstream from that. So you can remove duplicated logic, and you can simplify things to the maximum degree. All right, now the 5th reason to avoid imperative code is bad function names. So event handlers are interesting. Every time I've seen an event handler, almost every time, it has been named after the event that called it instead of by what it does, which is interesting because functions usually are named for what they are and not what calls them. They might be named for what they should be named for what they do and not the timing of their execution. This comes from the book Clean Code. It says, methods should have verb or verb phrase names like post payment, delete, page, or save. Let's look at this event handler or callback function. It's called navigate back. That's actually not a bad name. Imagine if it had been called back on click. That kind of doesn't make sense. This name is actually kind of obvious, but that's just because this is a simple function. But also notice that this actually doesn't describe everything that's happening in the function. We're also deleting search results. We're switching a flag to false. And this is the only line of code that this actually describes. Navigate back and router navigate back, basically. So what's the deal with that? Well, that's what I've noticed, that event handlers always have two types of names. One is when it's called, and the other is missing information. But how would you actually improve this function name? Well, what is it doing? It's checking if the form is valid. If it's not, it's showing a toast. It's clearing search results. It's fetching new search results. It's saving those results. It's saving the search term in the store. It's setting a flag to true, and then it's navigating to search. Is there a simple name you can think of that would describe all of that? I can't think of anything. I can think of a really long name that would describe it, but I can't think of a simple thing that I would want to type. So it's completely understandable that people would just type on submit, because that's at least partially helpful. It tells you that it's being called on submit, but from a strict clean code perspective, this actually doesn't help. So you might say, okay, well, that's because we need to make it a smaller function. But how do you make this a smaller function without making it more reactive? Well, these would be kind of their own, subroutine kind of thing. You'd extract this into its own function, but then what would you name that one? Save search results, save search terms, switch the flag, navigate. It's still doing a lot of things. So at every step of the way, it's just going to be like a tree of simplification and either loss of information or just creating longer and longer names as they encapsulate more and more functionality underneath them. Because a lot of stuff is happening fundamentally. Either you're going to be hiding important stuff, or you're going to be really struggling to figure out what the essence of all of this stuff is. Like, what is the commonality? What is it all doing? And that's hiding information, but it's at least doing it in a way that covers it. It's like an umbrella term for everything under this function. But sometimes this is the things in here can be so unrelated in different event handlers that it's basically impossible to come up with a name that encapsulates all of it. But you know what? I've never had this problem in reactive code, not even remotely, because this is this event handler refactored right here. This is part of it. And every part of it is like this. It only is concerned with one thing. This is a URL observable. It doesn't have to be anything else. All it is a URL. And maybe it comes from something else, but that's okay. Every variable that's defined maybe comes from something else. So that's just part of its definition, but all of it is still a URL. And so that is a very easy name to come up with. I've never just sat and struggled what do all these things have in common? Because everything is self-contained and has a single concern with reactive code. So it's for these 5 reasons, and probably more that I haven't thought of yet, that I think you should avoid imperative code. And it's why I think the whole industry of web development has been moving consistently for many years towards higher and higher levels of reactivity. In the React community, people tried ArcsJS for a little bit, but you don't really need it for synchronous reactivity in React because everything is always reacting to everything. So it's not fine-grained, but at least it's reactive. And so it's declarative. So you can say const A equals 5, const B equals A plus 5, and A will always be, or B, whichever one, the second one will always be updated with the new value from the first one because React is overreactive, if anything. So, however, with asynchronous reactivity, you do need something in React, and TanStack query, React query, that has gotten a lot more popular recently, and it's so nice because it lets you write async declarative code. So that's React community. With Svelte, they have synchronous reactivity, but they have Svelte stores, which have a limitation where they always have to be updated imperatively. However, I've heard of a thing called derived stores, and what does that sound like? That sounds like downstream reactive stores. So that's pretty cool. They should just use ArcsJS, but it's awesome to see it going in that direction. And then SolidJS, obviously, that's fine-grained reactivity. That's pretty great, and it has good ArcsJS support. And Angular has been just gradually moving more and more towards reactivity. So just very, very gradually, but still it has been. And yeah. And remember, everything used to be Vanilla.js and jQuery, and that was completely imperative. And then you get React and AngularJS and data binding and knockout reactivity, and those are very sloppy first attempts at getting synchronous reactivity. But it's actually reactivity. The point is declarative DOM, and it's convenient for all the reasons I've said in this article: separation of concerns, simplicity, fewer bugs, all the things. So, yeah, I believe that we'll keep moving more and more towards reactive code, including for async reactivity. And I think that the whole ecosystem is taking a long time because a lot of tools have to support it, because imperative APIs exist everywhere, and dealing with those inside of reactive streams and reactive syntax is really annoying. And so we're going to see more and more declarative wrappers for APIs, and like Three.js, that's an example where tons of declarative APIs popped up almost immediately as soon as it started being used in these various frameworks. So yeah, over time, people love reactivity, but you'll still see somebody. Like I saw when Josh Maroney posted a video about, I don't remember exactly what it was. I think dialogues. I think he mentioned declarative dialogues in one video. And one of the comments was like, yeah, but I don't want this, I want more control over what's happening. But that is such a weird position, because if you look at every other major framework, there's like 9 that I looked at and 3 component libraries for each. The top 3 all were doing declarative APIs for dialogues. Angular was the only unique one. So I think that there's nothing weird about doing declarative APIs, except that we're not used to it. And so that's the resistance. But if the only resistance to something is resistance to change itself, that's not going to last. The resistance is going to go away. So I would bet on reactivity. I would invest in RxJS. I would invest in state management libraries that support reactivity as much as possible. And I think the future is Solid.js and Quick, as much as Quick evolves its tools to let you have more reactivity, and as much as Solid imports from Quick, which it is doing. The $ syntax with Solid Start, that's a Quick inspired thing. So yeah, I'm excited about the future web development, and I am excited to stop writing so much imperative code everywhere. So anyway, yeah, please help me out and try to get more reactive code out there. All right, thanks. Bye.